So let me just say welcome to everybody. Thank you so much for coming today. It's a Saturday, but this is going to be an interesting event. I'm quite certain of that. So thank you for taking the time to come and hang out with us. So we have some introductions here. I should first introduce, the Middle East and South Asia Quantum Computing Group. Formerly, its name has been recently changed to Middle East and South Asia Quantum Technology Group. I figured that this is something more reflective of, the situation with the quantum science, information science scene. We're headed towards more technologies than just computing technology. So that's kind of the new name. I hope you like it. So we have a really nice session today lined up. We have Roy Perez from Volterra, who will be talking about printed circuit boards, and I'll let Dave De Silva, who's going to take over right after me, say more about Roy and his company. Let me just give a shout out to Joe Bookert, who I see is in the audience. We'll say something about him as well a little bit later. Dave will do that. And we have Vera, who's our media person for Dark Star Quantum Lab, of course, who's the sponsor of this event. And David Wilkinson, who is the CEO of the company. And I should introduce a special introduction to the Quantum Kid, Aaron Wang, who is in the audience, who also is Vera's son. He's our quantum genius. He's 10 years old, and he will be part of the discussion at some stage, I'm sure. I should now introduce Dave De Silva, who is the COO and Chief Project Officer of Dark Star Quantum Lab, who is also the Middle East and South Asia Quantum Technology Group's moderator, official designated moderator. So Dave, please take it away.
Well, thank you, Faisal. That was a wonderful introduction. Hello, everybody. I wonder if you saw us waving. That was the picture perfect start that Vera took, and I hope we'll take one at the end if you stick around. We're here for 2 action-packed hours. We're very excited to be introducing the Dark Leaf, a hybrid classical quantum circuit roadmap, and we'll be sharing some of the technology. You'll see the flexible circuitry that Roy Perez of Volterra, our partner, will be sharing. Roy hails from Waterloo. You can see him there in his Waterloo Quantum Garage, nicely set up with a couch. Roy, can we get a wave from you?
Hi, everybody.
We've been working with Roy for a couple of months, and we're very excited that new technology will be coming out of Volterra with the flexible 3D printed circuit board printer, and we'll get more into that. I'd like to acknowledge Sharanya, who is our intern, just like Aaron, the Quantum Kid. Sharanya has just graduated from Centennial College for technology. Congratulations, Sharon. There's a round of applause there. Well done. And while she was graduating, while she was going through her exams, she was able to create Robotica. Robotica will be shared today. She is a robot that responds to physicality, which will be building in terms of handheld circuitry that can even be imprinted upon the body. If you're a fan of Star Trek and Seven of Nine, you may recognize the jewelry. And what we're looking at doing is equipping our space lawyer. Marek is our space lawyer, and we'll be introducing her on another meetup. And it's really an exciting thing that we have happening here. Marek is involved with the U.S. Space Force, U.S. Air Force, with and other partners. So this is what we're doing here. And Sharanya, we're hoping that you'll wear some of the quantum jewelry as well, and we'll have it interact with Robotica. So there's a little roadmap of what we have here to create beauty and interactivity in terms of bringing humans and robots closer together in harmony. And there's more to introduce, but as this is a Dark Star meetup, it is my pleasure to introduce our founding CEO, David Wilkinson. David lives this incredible lifestyle where he keeps getting sucked into these. Did we come up with the term sort of secret? Is that our Dark Star term, or kind of top secret events? Sensitive is the correct terminology. And David receives direction from the US Defense Department, where we then take the direction. We pass it over to Dr. Faisal Shah Khan, who is our quantum muscle, and Faisal actually works out. And through his 20 or so quantum paper, or rather scientific papers, through his scientific papers, create the actual base, the scientific base, in order to project manage the technology. That's where it comes to me. And then we have our partners like Roy, where we're creating the circuitry, the 21st century circuitry, in order to be able to do things that were formerly only thought to exist in science fiction. We should say that we're all Star Trek fans, as well as Avenger fans. And you may discover that we'll be creating the technology through Roy's good work to bring our heroes to life. And in that way, we're hoping that Aaron, the Quantum Kid, will be wearing a cape one day. And so that's all further exciting things that are happening. So, David, any words from you, from our esteemed Grand Poobah?
Just thrilled everybody's here. Really excited to start the presentation.
Thank you for that. I've recognized Roy, and we'll learn more about Roy. I've acknowledged Sharanya, and as well as Aaron. We have acknowledged Vera. Vera is Aaron's mom. Vera is our media director, and she's been doing a lovely job in making sure that our work is top notch. We're very thankful for that level of professionalism. I think we should also recognize some of the key people in the audience. And to do that, I'm going to share my screen so that we can see the people who have clicked on our link. So let me do that now. Let me just set up my screen. And here we go. Forgive me if I look left and right, as I have three screens in front of me. The middle one with the camera, and click on share. Very good. On screen one, choose a share, and are you able to see my screen where I'm highlighting or pointing to the Middle East and South Asia Quantum Technology Meetup? Very good, thank you. Here we have the post, and on the post is, by the way, that's Malak. Forgive me if I'm not pronouncing properly, our space lawyer. And here we have Colonel Joe Bookard. Colonel Joe Bookard has been instrumental in supporting, for example, here Colonel has recognized, has tagged US Army DevCom, Joshua Bear from Austin, Texas, JJS, the Chief Technology Officer at the United States Air Force. David, you've been in conversation with JJ. Do you have a word of thanks to her?
Yes, we would just like to thank her for her patience as we get everything together to get back to her. So looking forward to continuing that conversation.
Thank you for that. We have the DoD Joint Artificial Intelligence Center, and we have some interesting work that Dr. Faisal Shah Khan has done in other meetups. And we have the Rock Island Arsenal Joint Manufacturing and Technology Center. The Colonel Bookard, we see that you're there. If you would like to say hello, give us a thumbs up, and we'd be happy to hear from you. Always happy to hear from our guests to see what they're excited about. Now that we
I'm sorry. Yep. Yeah, doing a little traveling here. I just want to say, hey, thank you for the invite. I'm looking forward to the conversation, and let's get on with it. Good to see everybody.
Good to see you, Colonel.
Thank you, Colonel. Very excited to have the Colonel here. So that is the Shoutouts where we recognize and shapes the work that we're doing here. Roy, that might be the first time that we're sharing that with you. Roy's company, Volterra, is in use with the U.S. Army and has a clearance with the Defense Department. And what's exciting here, Joey, is we'll be talking about what's coming up, the flexibility of their new product. And I think I've covered everyone for now. Faisal, have I acknowledged everybody I need to acknowledge at this moment?
I believe so. There's a oh, sorry, no. How about we acknowledge Alexander Jivov as well, who's also in the audience?
Yes. And Alexander has said he's stepping away momentarily a moment ago. Alexander is instrumental in creating the financial landscape. Just as in the stock market, there has been large gains because of technology like IT. What we're expecting in the quantum technology world is the next move up. We're actually expecting that Moore's law will scale. Many of you have heard of Moore's law, which says that computational power keeps doubling. It has stalled out, but maybe it's a stall out because quantum technology will then cause a jump, and not only a jump to catch up, it may scale up. And so we have a quantum exchange traded fund, or ETF model that is related to a SPAC, special purpose acquisition company, that relates to the IonQ, one of our quantum technology startup neighbors that Sharanya will speak about, where they're expected to bring in $2 billion. And so we have established Alexander, who has had previous meetups with us, who is in charge of understanding the financial model and identifying what the value may be. And this all has to do with achieving the circular economy. The circular economy is the point where there is more money being made than we can spend. It is a point of abundance. For those who follow Star Trek, it is Star Trek economics. And we believe through quantum technology that we're going to see leaps of productivity where through our product line, we have found a way, we believe, in order to help achieve that. But we're part of an ecosystem where we shout out to QCI, Quantum Computer Inc., which is a company where we share Dr. Faisal Shah Khan. They themselves have a $200 million market cap, and we have hosted them, or rather we have had them on our meetups where we're doing work through Captain Jeffrey Cole, a captain of 777 and 787 Boeing jet liners, the 787 being the Dreamliner, where we're helping to bring our technology into the marketplace. In this case, the non-defense marketplace, but there is an equivalent in the Air Force, and we're looking to be the caretakers to take care of that. So with that large picture in mind, let's bring it back to our current focus. I see that Malak has jumped up. Oh, that's great. Okay, Malak, if you're actually joining us right now, we would love to hear from you. But just before we move forward, I noticed that Zachary is in the audience. Zachary, how are you? Zachary is part of the weekly Quantum Kid meetup. And so what I'm going to do here is stop the share of my screen and new share, stop share. There we go. Okay. Yeah, so Zachary is part of Aaron's Quantum Kid meetup, where we have dozens of youth from age 7 to 15 who show up, and we talk about how is it possible that robotica is moving? How is it possible, and what does quantum have to do with that? What does quantum have to do with the Avengers quantum realm, Tony Stark's suit? And this is where Dr. Faisal Shah Khan talks about the technology and the possibility. And Zachary, is it your birthday? Give me a thumbs up if it's your birthday.
No, it wasn't my birthday. It was Isaac's birthday.
Isaac's birthday. Okay, very good. Well, we can let Isaac know that we've recognized him for his birthday. And so here we have youth who are coming into our adult world, and the two are coming together. And this is how we create a community. Now, with that said, it's my pleasure to introduce Roy in his where we have identified his place to be our first official remote quantum garage. We have our 22,000 square foot North Carolina quantum garage. Roy, I think yours is a little bit more compact.
Yes, that's right. That's right. And I have the most important piece behind me of the garage, the couch, of course.
I don't know if we have a couch. David, have we got a couch in our quantum garage yet?
There's a couch in there somewhere.
Okay, well, I like Roy's couch.
Nice. Nice.
Now, so Roy, if you would please introduce yourself as an application specialist,
sure,
and to talk about Volterra, and share with us what you're going to do as a preview. We're going to see some videos starting with your new technology. Maybe start with the plastic, with the flexible circuit.
Sure.
You can hold that up, perhaps.
Yeah. So these are two. Sorry, I'm having trouble seeing myself or my screen. But these are the two samples that I've created using our machine. A little closer look at it. This might help a bit. But here, you might see a bit of a glare.
You can see it.
Yeah. So this is a circuit I've printed with a quantum chip footprint. And it is on a piece of film called PET. It's a polyimide, and that allows it to be flexible. And this is our Flex ink in particular that I use for this sample, which allows the circuit to withstand these bends. So yeah, this is a little preview of what our current machine can do. And of course, with the new technology coming out, it'll just get better and bigger and better as we move forward. Yeah, I guess a little bit about myself as well. I am, like Dave said, I'm the application specialist. I have a background in electrical engineering. I studied here in Canada at McMaster University. And yeah, I work for Volterra. I've been working at Volterra for 2 years now, where I mainly connect with people like Dave and try to understand what their application, their specific application is, and how, and trying to pair that with Volterra and how we can help them move their development forward. So that's a little bit of what I do. I'll be going through a couple things for you, and like Dave mentioned, I'll be showcasing the new technology, what our teaser video for the new technology, and I can talk briefly about that as well. And I'll talk about our current product and our current machine that Volterra offers.
Oh, thank you, Roy. And to position this, we had a press release, and we were featured in the Quantum Daily about the dark leaf, which is we're calling our hybrid classical and quantum circuit with some flexibility, this functionality. What we want to do is to show how real this is. Whereas many of you have seen the $15 million golden chandeliers, giant equipment, where it's very rare to be able to find even a programmer. Dr. Faisal Shah Khan and his team, in fact, Nada, who is back in the UAE, are two recognized programmers of the D-Wave, another Canadian product, yay Canada, for expertise in quantum annealing computers, not quantum general purpose or quantum annealing. Now, the annealer requires specialized ability to code, something that we're actually taking care of with our partners, QCI, who have a product that makes things very simple. But what we're doing here today, though, is coming up with a new class of circuitry where we can upgrade or replace all circuitry and give it special abilities. For example, having security, provable security, as well as quantum sensing coming out. But we're waiting for Dr. Khan's paper on that first, and then we move it through the rigor of the technology readiness and manufacturing readiness process. And that's what my bailiwick is. And David, of course, guides it at every point by showcasing and talking at these DoD events, which are really exciting. Now, coming back to Roy here now, you have background and experience with the Defense Department, and the new technology. We're very thankful that you are helping us construct something that's never been done before. The ability to create circuitry, and in that flexible layer is something that where you take a piece of hard technology out, and what we're doing now is drafting in something flexible. Kind of think of it as when the Terminator first came out, they were like very robotic. Now, Sharanya, you're our robotic manufacturer. Could you please show us the robot dance, very robotic? It's okay, Sharanya. I didn't warn you I was going to do that to you. When robots first came out in Terminator, if you're a fan of that franchise, they're very hard, and you knew they were robots. So, and then the more advanced robots were flexible. You could you could touch them like this. So, Sharanya, could you show to everybody that you're not a robot, that you're like flexible? Thank you. We're not sure because her robots appear a little bit too sophisticated, because she had a team of 4 people who tried to do it and it wasn't possible. So we're not quite sure if Sharanya is from the future or not. Anyways, what we've got here is the ability to catch up with Sharanya's future technology with flexible circuitry. Can you imagine flexible robots that are able to work hand in glove with humans? We do have a little presentation about that Aaron has created. Aaron, the Quantum Kid, has created the quantum comic strip, which brings the whole thing together. So Roy, thank you for that moment for us to be able to explain how important the work is here. And we're excited about that video. It's so cool. Back to you, Roy.
Yeah, awesome. So I'll go ahead and share my screen now. And you should be able to see my screen. Is that right? Yeah.
It is resolved for me. Thank you.
Okay. So I'll go ahead so this is a teaser video of our new product coming out likely in Q1 of 2022. It doesn't go into too much detail, of course, but we can chat about it a little bit afterwards. It's just a few seconds here.
Oh, I have a wonderful electronic invention I want you to see. It looks something like this.
What if we were entering a new era of electronics, where the devices of tomorrow are more than just fast? They're flexible, lightweight, biocompatible. Get ready to explore the next generation of additive electronics.
Awesome. So yeah, that's a little teaser for Nova that's coming out, and the idea behind and the mission of Volterra, I should probably mention is being the provider, the sole tool provider for any additive electronics project. So this of course fits hand in hand with what Dark Star is trying to accomplish, and the initiative with Dark Leaf with flexible circuits, biocompatible materials, stretchable wearables and textiles, that sort of thing.
So this is fashion. This is fashion in the making.
Exactly.
If you could unshare your screen, that allows for Vera to be able to choose after the fact. So we want to see happy faces. So I was blown away when I first saw that. I was blown away. I'm still blown away. And by the way, Sharanya, that was a cool accent there. That lady on the video. We might need you to like do that when you're talking. Give it a little more. Now, what I hear right, Roy, when it was biocompatible?
Yeah. So what they mean by that is there are a lot of researchers and other R&D groups that are looking to deposit a biocompatible material. So, for example, think of contact lenses. Like contact lenses, you've kind of seen smart glasses and that sort of thing, but there are groups out there who are looking to deposit a material, for example, called PEDOT, which is sort of like a toothpaste, but it's biocompatible in the sense that it can be embedded into contact lenses, for example, and they're doing things like that, and they need tools like Nova, for example, to kind of further that development. So that's one example in terms of biocompatible materials and biocompatible substrates.
That is fantastic. So that means, so biocompatibility means, in my mind, technology that is bio-based. This aligns, as you said, with the Dark Leaf.
That's it, guys. Come over. Let's eat.
Oh, hey, Joe. We're able to hear you there for a moment. I like it. I like, though, that you mentioned food, because this is definitely food for thought. And there you go. Colonel Booker. Roy, I love that the theme here is biology, and Dark Leaf ultimately is about food. Is about living tissue, which includes food. Not that we'll be eating, not that your printer. Well, maybe your printer is a predecessor.
Right.
Thanks to Colonel Booker's mention, maybe it's the predecessor to the replicator. Holy smokes. Dr. Khan, would you please speak about the replicator for a moment with your scientificness?
Sure. Thank you, Dave. So yeah, Star Trek has this amazing technology, right? Which is all part of the quantum teleportation idea. The transporter beam that sends, the information contained inside a human body, for example, to another part of the universe, right? However far that may be. And the same technology is actually used to replicate food, edible food and nutritious food. So of course, this is right along the lines, right? Of course, at the moment, I'm thinking more like, the material with which the flexible circuit is built might be edible, right? That would be nice. It's like, hey, I'm hungry now. Let's eat the circuit. What it actually really reminds me of, this flexible sheet that you showed us in the beginning, Roy, was a scene from the movie, the reboot of Total Recall. I think that happened 5 years ago. The original movie was made in 1980s at some time in the 80s. There's a scene in which they show that the mobile phone technology is actually embedded inside your wrist, right, inside your palm. And that's when the guy, there's one gruesome scene where when the protagonist actually cuts open his, palm from the side and pulls out the the flexible sheet of circuitry. That's exactly what it looked like. So that's what it reminded me of.
That's awesome.
Dave, back to you.
Oh, well, thank you. Well, we can what makes you think of though is medical applications here, where we're able to like the $6 Million Man. $6 Million Man is a TV show from my childhood where an Air Force pilot crash landed, and then they said, we can rebuild him, we can make him better, and they inserted bionics. So the potentiality here, Roy, and please qualify this, is that we can use the technology to be able to create layers of even flesh. So rather having robotic, hard, cyborg technology, we can rebuild it and give you special powers. This sounds very magical, as it just occurs to me. But with Faisal here keeping us grounded, what I'd like to know from you, Roy, because you mentioned biology, is that something you guys thought about, or what's your opinion on that?
Yeah, I mean, that is kind of the transition for technology these days, right? Everybody's trying to create the next wearables. We have all sorts of companies doing that in textiles and not necessarily flesh per se just yet that I've heard of. There could be companies out there or groups out there doing that exact thing, but yeah, that is, I mean, this Nova is just the first step. It is just a foundation for us moving forward, and we do hope and we are planning to build upon Nova. Essentially, it is just the first step, and it could very well be building layers of all sorts of biocompatible circuitry.
Well, that's wonderful. Yeah. I'm hearing from Mr. David Wilkinson that there are some thoughts that you're having, and I'm excited about that. So we'll have a private conversation about that, David. Thank you. I'm glad that. So what has happened here in this interaction with input from the audience is creativity has just emerged. What's exciting to me is it's aligned with what Volterra had in mind. I was not expecting this conversation to be this advanced. I was expecting our conversation to be merely the fact that quantum can be inserted right now. As you pointed out, there's a very tiny spot there for the quantum chips. The quantum chips that were available to us, the QRNG chips, quantum random number generation, are very, very small, and they can be inserted into micro places, a far cry from the giant chandeliers, which would be very awkward to try and put. At best, we could put it on our head, perhaps. That might be comical, but not effective. Perhaps we can have a moment and hear from Dr. Faisal Shah Khan. As I mentioned, we both mentioned the quantum chips. I called them out as QRNG, or quantum random number generation. Faisal, could you give us a little bit of background on that?
Sure, happy to, exactly. So these quantum chips, as we're calling them, they're basically, what makes them quantum is not what they look like or what they're made of. They're made of the usual, technology that every other chip is made from these days. What makes them quantum is the fact that they can process and harness certain properties of quantum physical systems. And the particular property they can harness is that of true randomness, or which produces maximal entropy, which basically means that any data that comes out of this chip will have minimal to no patterns in the data. Now, that's a great property, because if you put that in the context of information security, of electronic communication, it's godsend, because right now what happens today is that we have random numbers generated from our machines that we use, like a mobile phone or a computer, to encrypt data. But those are not the so-called random numbers aren't exactly random. They are actually algorithmic. They have an algorithm behind them that's producing them. And with a dedicated opponent, if I can call them an enemy, harsh word, but anyway, that opponent or enemy can, in fact, if has enough resources available, can figure out what that pattern is, what the algorithm is. It's not that hard these days, with the dedication that you see out there amongst hackers and certainly government-sponsored hackers. So what you need is a methodology, a physical system that produces complete true randomness, which can only happen in a quantum system, really. It doesn't happen in what we call a classical system that is not quantum. So the fact that now you have these quantum random generation ability on a chip, which is a nano-sized, really small chip, that you can actually interface with any piece of regular technology that you have, right? Be it a phone, be it your computer, some piece of your computer hardware, gives you the ability to produce randomness in a true sense and basically mask your data with an algorithm that doesn't leave any pattern behind, right? For to give away a weakness in that sense. So that's, I think, what the true power of this is. Now, to be fair, though, I should point out there was some comparison, Dave, you made between quantum computers that are in a chandelier, and yes, I agree they would look nice on the head if you wear them. They're very beautiful looking chandeliers, but those are inside those chandeliers are you could say quantum chips, but those are not producing random numbers necessarily. The idea there is to actually control that randomness in a way that you can get increased speed of computation, or perhaps get some kind of enhanced result when in a particular application domain, like, say, for example, high frequency trading, right? I mean, I recently wrote a paper with Ning Bao at Brookhaven National Lab, and we showed that in the high frequency trading domain, if you use quantum computing, it's not the speed that's really the important thing, even though it is to a certain extent useful. It's the fact that you can avoid situations, suboptimal situations in terms of payoffs is actually what's so remarkable about using quantum computers over the cloud to do high frequency trading. So just a little bit of context, you can certainly use QRNG technology there as well for increased security. And of course, now going back to the topic today, how do we make that happen, in an easy way? We don't want it to be like, something that's happening in a lab, national lab. We want to see if we can do it in a garage, right? So this is why Roy is here and Volterra is here, and we're trying to see how to take, one of these quantum chips, which has true randomness capability, and interface it with a classical, hardware piece, and see some sort of enhancement, be it security, for example. Dave, I believe you're on mute.
Yes, thank you for that. That's exciting, and there is a connection here between your quantum game theory paper, is how I like to call it, optimizing decisions, which is the heart of everything, perhaps, certainly in the human domain, where that involves these quantum random generation chips, which will be able to insert into technology and perhaps support people more directly, given the fantastic conversation we had, which directly began to relate to Star Trek technology and other science fiction technology. By the way, the cell phone is Star Trek technology. It was invented because someone liked Star Trek, and so it was invented. There's a white paper on that on my LinkedIn. Now, so Roy, we've created more context for you, and back to you and your talk.
Mm-hmm. Awesome. Yeah, I'll go ahead and share my screen again. Give me one moment here. I should be able to see my screen. Is that right?
Mm-hmm.
Perfect. Okay, so a little bit more about what we currently offer here. It's not perfect. Okay. So right now we have a machine that I've used to create this flexible circuit. I'm not too sure if you guys can see it anymore, but the machine that I use for that is our current product, the V1, the Volterra V1, and it's a multifunctional PCB printer. Um, and where we find that people get the most value out of it are in three different verticals here. So product development, and that kind of ties in with Darkstar as well as research. Research and other sorts of wearables. And in this case, it's a wearable RFID tag produced by Stanford University here in that picture. And education. Volterra, like I mentioned, our mission is to be essentially the catalyst for innovation. And that starts at a very young age with Aaron, with Zachary, and his colleagues. It starts at a very young age to educate the next generation of innovators and engineers and product developers, and teaching them the fundamentals of electronic design. So education is a huge portion of Volterra's mission.
And Roy, if you go back to that slide for a second,
Sure. Yeah.
I noticed Shannon there.
Yes, that's right, Shannon. So yeah, a little bit of a background on Shannon. She, I believe she graduated now, but she was an undergraduate student at Princeton University, where back in this past March, she actually had some printed circuit boards made with a V1 sent out into space in NASA's most recent launch back in March. So she had no real background in electronic design, but her choosing of Princeton's undergraduate program allowed her to fully conceptualize and visualize and design circuitry that she got to experience and physically launch out into space through the program. So I can share a little bit about her as well afterwards.
That's great. So what's exciting here, and where it connects to Sharanya and to Aaron, is the young lady there. She created, using Volterra, a printed circuit board, PCB, that was inserted into a cube satellite that was launched. And the plan here is, Sharanya, for you to meet Shannon, and we will have an interplay as part of what we're doing is to work with the U.S. Space Force. What Shannon's done is beautiful. Aaron has actually created a comic strip that includes Shannon, and we want to share that with her through Volterra. So back to you, Roy.
Yeah. And there's already been talks and we're lining that up as well, Dave, as we speak. So
thank you.
That's perfect. Yeah. So the desktop PCB printer, the V1 isn't meant to replace any sort of PCB factory. It is really meant to keep everything in-house, keep everything close and at home, and allow you to iterate and design quicker to get you to a final proof of concept. Software, for example, software engineers typically have it a little easier than hardware designers. They have programs that they can easily debug and tells them where the errors are, or gives them some sort of idea of where things are wrong. But for hardware engineers, we don't necessarily have that luxury, unfortunately. So the desktop, the V1 is really meant to get you to iterate quickly and get you to a final design very quickly. So how does it work exactly? So the V1 has 4 main steps to it, and this is kind of the workflow that you would bring to the V1. So first, you'd have your brilliant idea. You would design it in your CAD tool of choice. So any PCB design software nowadays, it's Eagle. Upload the file to our free software. and then quickly calibrate to ensure that it knows where the print area is in real time space. You would drill and print both sides of the circuit, thermally cure, and then you would apply your solder paste, your rivets, your components, and reflow, which essentially just means making the connection between your components and the circuit that you've designed, and then you test that board. Sorry, Dave. I'm not sure if you were there or not.
Oh, okay. Sorry, I don't know. You faded out. I think I faded out. I was just saying reflow is put it in the oven and let it for a few minutes.
Exactly. Put it in the oven, let it bake, and exactly put it in there for a few minutes. So these were the 4 steps or 4 main functions, I should say, to the V1. So you first would drill your through holes, and this can all be done with flexible circuitry as well. And then you would print your traces, your conductive ink onto the material that you're using. In many cases, it's PET or FR1, FR4. You would precisely dispense solder paste, which is just, again, making the connection between your component and the circuit that you've printed. And the last step would be to reflow, which is, like Dave said, essentially baking it, putting it in the oven, and solidifying the connections between the chip and the circuit that you've created.
So Roy, for those who are new to printed circuit boards, and the majority of the audience may be there, when you showed this to us the other day, I was fascinated to understand the basics. So number 1, just to review this again, is drilling. Right?
Correct.
There is a green board where drilling happens, and the green board is the what will become the printed circuit board. It's the board.
Exactly.
And this particular one, the Volterra 1, which has been highly successful, it uses for the most part, and this is an example of a non-flexible. Although what you showed us was flexible, which can be done on the current technology. Is that correct?
Correct. And the reason, I guess, to further elaborate on the drilling, why we would drill in particular is essentially to make connections from 2 different sides of the board, so you can maximize the space, essentially, the real estate of the circuit.
Right, a multi-layer circuit, just like the human body. For example, the skin is a multi-layer circuit, where the top of the skin has a layer, and below that is a secondary layer. And this is now typical, I think, a double layer approach for PCB printed circuit board. Is that correct?
That's correct. Yeah.
Okay, that's lovely. And then looking at number two, then it looks like it's drawing.
Yeah, exactly. So it's drawing out the different wires, and think of it as if you had a breadboard. If you're not too familiar, it's kind of the old way of prototyping, but you're jumping the wires, and this is a more polished version and something more accurate as to what a manufacturer would produce.
Yes, and the drawing is ultimately around the chips, where there are chips that are inserted, which are a step coming up, and the drawing is the design in order for the chips to communicate in a compact way for the circuit to work. Would that be a correct statement?
Yeah, exactly. And what makes it conductive, or what allows electricity to run through it, is so that's a silver nanoparticle ink that's being deposited on the green board itself, and that allows it to essentially conduct electricity and get the necessary power to the components around the circuitry.
Oh, that's cool. Now, the active word for me there was nano, and we have Aaron listening, our expert 10-year-old, where I think it was it yesterday or a previous Friday, Aaron and Dr. Faisal Shah Khan and David Wilkinson and I, with the Quantum Youth Group, talked about the nano as in Iron Man's nano suit.
That's right.
So we're seeing the ability to craft, especially with the flexible component, layer by layer of a potential nano suit.
That's right. That's right.
That's very exciting. Then we move to number 3, and please remind me what step number 3 is essentially.
So step number 3 is we're dispensing solder paste, which is another metal alloy that makes the joint between the component and the traces that was previously printed.
Very good.
You can see it printing specifically on certain squares, essentially on the flexible or the green board there.
And the squares are where the chips go, whether they're classical chips or the quantum chips. Is that correct?
That's right. Exactly. And some chips come in all different shapes and sizes. So the software itself takes that into account and adjusts accordingly depending on what we're looking at.
Very good. So step 3 then is the step just before the chips get placed onto the board.
Correct. Exactly.
And then on step 4, I see some chips. I see the classic chips that I've seen when I open up a computer, a PC, right there, as well as what looks like capacitors, which are the round, taller chips.
That's right, exactly. And you can see the metal is sort of liquefying and eventually solidifying between the chips and the circuit.
So step 4 is making the chips. So when I think of the Iron Man suit, the early versions of the Iron Man suit, they were robotics that were attaching the parts to him. And so step 4 is like the active chips, the technology are being attached and then they're riveted on. But in this case, it's done at the circuit board level, which would be included in Iron Man's suit. Yes?
That's right. Exactly.
Now, a benefit here is with the flexible circuitry, and we have subject matter experts on this, is that they're control surfaces. So for example, the shoulder will have a flap. And the ideal thing is with a flexible circuitry that can become stronger or lighter as required, especially with the introduction of biosynthetic material, then by having active circuitry, they have the surfaces themselves can emit or resonate power. Ultimately, through quantum mechanical processes, we may have the stub of creating a nanoparticle suit that was featured in Avengers. Was it Endgame?
I believe so.
I think it was Endgame. So Aaron, yeah. we'll have to bring that back to the Quantum Kid Youth Group, who are experts, and we'll discuss that. We'll create some models, the pictures that we're showing after Roy's talks. And also, Faisal, I'm going to ask for your son, who is the cardboard robot son that you've created because you're a not so evil scientist. And you create children to do the biddings of the quantum world, where your son Rohan has offered on his own to create a Minecraft world where we can simulate the technology and have children show up to discuss. And from Aaron's group last night, there was a raised hand after the meeting asking if they could be in the group and be part of your son's team.
Sounds good. I'm sure Rohan will be very excited to have a team working with him. I'll talk to him, and maybe Aaron and Zachary and the rest of the youth group can work together and figure it out. Absolutely.
Very, very nice. So in this way, Roy, we're bringing these genius-like minds, Aaron's friends who he's attracting throughout Canada and around the world to then provide you with support, which will be electronically modeled through Microsoft Minecraft, and then we can have some fun with this, Roy. And
Absolutely,
of course,
yeah.
Sharanya makes the robots. And
Right.
Sharanya, we may need you to be an Iron Woman.
Dave, if I may comment something here with respect to number 4 on the screen right now. Right there, we see a chip, almost like, Borg from Star Trek, getting absorbed into the circuit, right? So, Roy, would it be accurate to say that this is where a quantum chip would be placed on a regular circuit and interfaced?
Exactly. And I'm not too sure. Do you guys see me on camera as well, or just my screen? You also
Yep, we see you.
So I'm not too sure. I can't see myself, but there's a very small portion here, which is exactly that you see in number 4. But this is where you would put the quantum chip, and we've actually taken a quantum chip footprint and designed a circuit around it, and something like that would go right here, which is smaller than my pinky fingernail, essentially. So you got it exactly right, Dr. Khan, and that is where a quantum chip would go and essentially be placed on a circuit, and that would, of course, depend on the design.
Exactly. Now, with Dave's permission, it can happen now or it can happen later. I would like to have a small, quick discussion about how do we make the two chips, the two, circuitries talk to each other. I have a quantum chip, now I have a classical circuit. As I said before, the quantum chip is not quantum because it's made of some kind of, quantum object. It's the fact that inside it, there's some quantum mechanical processes that we can access and then utilize. So how do we make these two things talk to each other and produce a functionality that can be put to good use?
Well, I think that's a good question. So what I'll do here is I'll state my understanding, and then we'll turn to Roy for his statement, and perhaps Sharanya, who builds PCBs. Thank you for that, Faisal. My understanding is that the quantum chips, the quantumness is inside, but it comes out into the classical world as an electronic circuit, sort of as a signal. The signal it can then be utilized in the classical world. In that way, for Roy, my understanding is he does not have to treat the quantum chip any differently from a regular chip. However, what's very different is that in order to control, in order to utilize this, a special piece of software is required. Now, what we have done as part of our dark leaf technology, our architecture, we have the dark box. And the dark box is a place where we mate the classical and quantum skills or features of the chips. It's just programming. However, the programming is special in that it comes from the circuitry diagrams that Dr. Faisal Shah Khan has created. So we're creating a stepped process very similar to how in the old days with the ENIAC, that first giant computer, you had to program the OS, you had to program the application, you had to program everything at once. Where we're creating a stepped process, a CAD-CAM, computer-aided design, computer-aided manufacturing. Roy represents the CAM, computer-aided manufacturing. We are bringing together a quantum ecosystem, including some of Faisal's partners through MESA, the Middle East and South Asian Quantum Technology Meetup Group, where we can mix and match and use the best out there based on Faisal's process, where I come in and say, okay, we can manage this and have a way of moving up. And I'll identify QCI again, where they have their software which allows for a simplification. So in this way, in this dark box, we're bringing in the best of the quantum technology meetup group in the world, as well as the requirements of the DoD, as there is a line in the sand. There's a line in the sand, and because of the open architecture requirements of the DoD, the Defense, the Department of Defense in the US, because of that requirement, we have a way of harnessing the quantum random number generation chips where we're able to have a line in the sand. So only the right things go through, even though it's an open environment. And in this way, it adds an imperviousness to hacking, which is based on well-known and commercially available products that we're now refining, all based on Dr. Faisal Shah Khan's papers, where we scientifically prove this can be done, and we have rigorous testing mechanisms. So coming back now, Roy, that is my understanding, and I saw you nod your head. But please give us the qualifications in terms of, for you, it doesn't matter what chip is lined up here. It just has to be mated, because the chip itself has connectors, and as whether it's a classical chip or a quantum chip, it simply works. And that's the part that you do. I'm going to ask for your thoughts on that, and then Sharon. Thank you, Roy.
Sorry, I didn't mean to cut you off there, Dave. But you guys hit it right on the head there. It's not any different from the traditional ICs and chips that are out there today. And like you mentioned, it is dependent on the firmware designed through the chip and the software programmed around it. But it is from a manufacturing or from a hardware perspective, it's not different at all. So yeah,
still got to solder it in there somehow, right?
Exactly.
Okay, and then so thank you for that, Roy. Sharanya, does what we've described, and in terms of you actually crafting active printed circuit boards in an active robot, which we'll be sharing during this meetup, does that sound right to you?
Yeah. Thank you, Dave. Being my mentor, I'd like to thank you for this great opportunity that Darkstar is acknowledging me that where I belong. So I think it's more related to my project, which is robotica. Since I'm using the rigid robot PCB, I think the flexible PCB will reduce the size of robotica and give her the flexible design. And I'm familiar with the 4 steps, so I can relate to my project.
Okay, very good. That's what we wanted to hear, because we're actually learning from each other. This is not rehearsed. We're sharing with the world our actual process, bringing minds together, where new ideas show up, and we're educating our group as we move. So thank you for that, Sharanya. To you, Roy.
Awesome. So the next thing I have lined up is a walkthrough video of the V1. And you'll notice there might be a little bit of hammering and banging in the video, but it's not a typical thing. And this is just for this specific application. You'll notice that, but it's not typically done depending on what you're creating. So here we go.
Hi everyone, I'm Kat, co-founder at Volterra, and today I'm going to be showing you how to make a double-sided circuit board with the V1. So step 1 is to upload your design files. You can use any software you're comfortable with, just upload them into Gerber format. You'll see the toolpath is already calculated when you upload your design. So next, clamp down the sacrificial layer and the board. I'm using an FR1 board because we're going to be drilling into it. So once that's secured, snap in the proximity probe. It will be used to generate an accurate map of the surface. So once that's done, go ahead, snap in the drill head and fire it up. Now the board has been mapped in XYZ space, so the drill knows exactly where to go. If you're going to be using different hole sizes, the software will prompt you to change the drill bit after the current hole size. All right, let's print some traces. So swap out the drill head for the ink dispenser, let it calibrate, and begin laying down conductive ink. If you find a mistake on the board, you could easily reprint it using selective printing. This is a great feature for design modification and rework. Okay, so now it's time to cure this board. Simply remove the sacrificial layer, flip the board, and rest it on the baking ledges of the clamps. Curing takes about 40 minutes, and you're going to want to let it cool down after, so I'm going to go grab a snack, and I'll be right back. Okay, so that looks good to me. Now I'm just going to flip the board back over so that we can print and cure the bottom side. Okay, so our traces are printed and cured onto both sides. Now I'm just going to go pop in some rivets and use the riveting tool to secure them into place. Okay, with that done, we can clamp the board back onto the printer and go ahead, snap in the solder paste dispenser so that we can get some solder onto these pads. And with that done, I'm just going to pop some components onto here and watch them reflow directly onto the heated bed. This board does have a few through-hole components, so I'm going to go solder them using the provided solder wire. I'm using plenty of flux, and my iron is set to 200 degrees Celsius because the traces are heat sensitive. Okay, so let's see if my punk console works. Okay, so this is an example of a very simple circuit. Thank you all so much for watching. We can't wait to see what you create with your V1.
Awesome. And that was my colleague, Kat. She's one of the original co-founders of Volterra. So.
Hi, everyone.
Okay. So yeah, one thing I did want to point out is the solder and reflow functionality of the V1 because it's an additive process and the keyword is additive. You can skip certain processes that are traditional to manufacturing of PCBs, whether that's flex or for rigid substrates. So the additive is the key word, and that's something we're really pushing for with Nova. It being an additive machine, the bigger brother of the V1, allowing you to not just dispense solder paste in this case, but other sort of materials that are particular for Darkstar's example, biocompatible materials.
Roy, did you see we've got a question here, which is, Roy, what software are you using to save the fabrication designs, Windchill, Raptor, etc.?
Yeah, to save essentially what you'll need is any sort of PCB design software. So whether that's Altium, KiCad, Eagle, as long as you're exporting it as a Gerber file, our V1 software takes that in and generates the tool paths from a Gerber. So any sort of PCB design software that you're using, whatever you're comfortable with, would work well.
So Roy, so it sounds like standard software. We'll write those down. Now you said Gerber. When you say Gerber, I think of baby food.
Right.
Now, do I have that right?
Yes. So Gerber is correct. It's not baby food, but that is the standard file format for PCB manufacturing.
Yes. Okay. So I think we can have some fun with that, Aaron. When we create the minutes for this meeting, we'll have a slide where we're trying to figure out what Gerber means, and we realize it's not the Gerber food that Roy is speaking to. Now that file, Roy, this is the design stage, and the design stage is basically it's just the file that your printer uses. And my understanding of Gerber files is they're pretty standard.
Correct, exactly. If you're familiar in the PCB design space, Gerber isn't anything out of the ordinary. There are plenty of softwares out there that would produce that, and some that are more friendly for students and educators, and some that are more for industry standard, like Altium and Eagle through Autodesk, for example.
Very good. And
hey, Roy, this is Joe. Hey, Roy, this is Joe. Hey, thanks for sharing too. Wanted to know that type of software because it really extends the distribution network as well.
Right. Yeah, and we wanted to obviously make sure it's something that a lot of designers and engineers are familiar with.
Accessible.
And exactly accessible. So even with Nova, I think we're going to be expanding the inputs, the design inputs, design file inputs, I should say, to more than just Gerber formats, because people who are designing with flexible circuits are using vector programs, for example, to create different patterns, and they're not necessarily familiar with PCB design software. So we are hoping to make it even more accessible for the next product launch.
That's cool. That's quite exciting. I like the vector program expansion. I'm becoming educated in this. Sharanya's our PCB subject matter expert. Sharanya, I keep throwing all these YouTubes at you. Hey, Sharanya, here's another YouTube PCB. I'm sure Sharanya's going, David, stop that. I know this. I learned all these things.
No, actually. I like to answer in a different way. Actually, that videos has helped me so lot. Literally, it helped me because my PCB course in school, which has only three of the exercise with PCBs. So it helped me a lot to do the assignments for Dave, which will help me for the course in school.
Oh, I'm so happy to hear that. We should take a moment just to recognize Sharanya. One of the challenges in school is there's a gap. There's a gap between what you're taught and the reality. And Roy has been instrumental in crossing that divide by providing us with the information you've given us, Roy. And I've been giving that to Sharanya and then overloading her with information. And you've done a wonderful job, Sharon. I really appreciate that. What we're trying to do here is set a standard. We're trying to set a standard around the work you're doing, Roy. Your product is state of the art that I found in the world. I'm so happy that you're in my backyard, an hour and a half away from me at Waterloo, where I went to school. Right. And what we're trying to do here is work with the colleges, for example, Centennial College, where through prime students, and I found Sharanya, I found her, and then Sharanya was like, I thought, this person is really good. I like Sharanya, and then have been overloading her in her final year in order to be able to work with Roy. And then she blows my mind, which we'll show afterwards with a robot that works that even a 4-person team couldn't put together. So what we'll do is later we'll find out from Roy what the vector software is, Sharanya, and I'll begin overloading you again with the background in order to create the flexible circuitry so that we can create the cool Iron Man type technology that Aaron and his group of 7 to 15-year-olds create. I think Aaron is actually drawing right now. He did that on another meetup, and we actually embedded that. Oh, excellent. We actually embedded that in our work, and we presented to Joe. Joe, thank you very much for your questions as you're representing a number of parties. And in the end, all we're trying to do is align our team, our group, to that which you are presenting. And of course, through David, who has access to more information, and we're just bringing it all together. David, do you have a comment?
No, it's just it's very interesting to see the whole process here. Really, I think one of the things that I miss is that reflow process can really eliminate the need to come in and solder at the chip level when you're doing that integration. It just kind of melts right in. That's awesome.
Right.
That was really neat to see.
Yeah.
Now,
and chips are getting smaller and smaller, so it's harder and harder to hand solder, for example, right? So we did want to eliminate that completely and make it easy.
That's fantastic. Yeah. Really awesome.
Now, David is learning from the best. We have James at our 22,000 square foot PCB facility, essentially, where James is the type of person who has rows and rows and rows of all these PCBs that you've never seen before. He is an expert in reassembling and creating what was said to be impossible. There's a nice shot in our press release with David and James working on products. So one of the things we're looking at here, Roy, is outfitting James, who might be a unique expert in the world, to be able to play with your printer and use it in a real-time environment, especially with what's happened, David, with the interest in your podcast about retrofitting certain equipment. David, there's certain things you can talk about that you cannot talk about. The podcast, I don't think yet has been released, but I'll turn it back, give you the microphone for a moment to talk about that, as it is written in the press release from your quote, David.
Great. I like you said, I don't want to speak too much on the subject just because it's kind of still getting hashed out. But the objective is to kind of eliminate this kind of materials bind where you've got products that have been, have been in use since the 1980s. Companies like GE and Siemens, who are staples in the manufacturing automation industry. Allen Bradley, again, another example. And these components, these boards that have been in use for years are starting to break down. It's actually quite difficult to get the replacement components or to get replacement boards. And what happens is if you've got an automated facility and the line goes down, that's tens of thousands of dollars every second that the line is down. So what happens is there's a situation where it's kind of a mad, desperate sprint to try to locate a replacement part. People, especially we don't like to see the DoD overpaying for something like that, and then they end up sourcing it. It could come from, say, a fab in another country where they're not able to really properly review the security protocols, where they're not really able to properly test every component that gets built in. So this is kind of a pressing need right now, and one that we're working hard to get a solution for, and hope to have more on that soon. Excited to talk to Roy about that more too.
Oh, well, thank you for sharing that with Roy. It helps Roy understand where we're going with this, and we're looking forward to that podcast actually being published.
And I've heard from Mark Good, and he has been editing the podcast, which I'm sure he had to do a lot of because I was talking. So I'm sure that's taken him a while, but he's getting ready to put that up. So that should be also soon to follow.
Oh, we look forward to that, and perhaps we'll pass that to your friends at the Quantum Daily, where we're thankful for their support. Before I give it back to you, Roy, Faisal, you started with a question, and we've had a round robin discussion about that. Have we answered the question to your satisfaction?
Yes, I think the question was answered quite early in the discussion. What came out after that was a really interesting bonus. I mean, I really enjoyed that. So thank you for that discussion. Absolutely. And I should mention that Joe has responded to David's discussion, his comments, by saying exactly. So just wanted to mention that. Back to you, David.
So we're on the right track.
Oh, okay. That's great to know, because this is live, ladies and gentlemen. This is live what we're doing here. This is all about bringing the best together in order to solve for constraints that the U.S. government has. It's very exciting to be able to do this and to receive this feedback. Before I pass it back to you, Roy, I just want to give a shout out to Isaac. That Zachary, who spoke a moment ago, I think it's Isaac's birthday, and Isaac wants to be on the team with your son Faisal, with Rohan, and I think for his birthday he wants to get like a drawing tool where he's going to help Aaron the Quantum Kid draw. We do a lot of drawings on our meetups, and then we turn that into comics. So shout out to you, Isaac. I'm not sure if you're here or not. Go ahead and text us if you can, and if you have comments, we'll build that into the conversation. So thank you, Faisal, for your feedback. That yes, the question was answered right when Roy was doing this, I think, and I very much enjoyed the conversation, the round robin. And now back to you, Roy, as you were just completing step number 4
right.
for your video demo. We'll let you complete that, and then we'll do an unshare so we can see everybody's faces again.
Sure, no problem. We don't have too much longer on my end, so this is again just completing the last step and just showing it in a little bit more detail here. The reflow process, baking the circuit, and integrating everything and putting everything together essentially. So that's just what's happening here.
Beautiful.
And yeah, like we've mentioned and talked about this session, is it's not just for rigid and traditional PCBs, which is still a large factor, but for groups like Darkstar and Dark Leaf initiatives, there are new opportunities out there for printing on flexible materials, on textiles, on stretchable materials, to kind of expand our imagination in terms of electronics, and not just kind of stick to the status quo for what's being made out there right now. And the additive process, of course, you could see you can also thermoform things and different substrates and different circuitry on different substrates. So on the left, you'll see a heater printed on a very similar flexible film that was thermoformed onto a 3D printed substrate. And that way, you can conform the circuit into another 3D object. So these are just some of the opportunities, and with the V1, we've kind of just touched the surface, but with Nova coming out, we really hope to expand the possibilities with what additive electronic engineers can do. And just a little bit about our users and our industries. So we have aerospace. We're very heavily in the aerospace industry, consumer electronics, ag tech, automotive, education, especially lighting, IoT, augmented reality, virtual reality, clean technology, robotics, military, of course, industrial electronics. We have companies like NASA and Microsoft and various groups within the military using the machine today, and they're the ones kind of expanding the creative and imaginative ability of electronic design. So a little bit of where it's used in education, academia. We have Oxford, Stanford, UCLA, MIT, of course, using the V1. And Mike Galvin at Princeton and Shannon at Princeton are using it to launch CubeSats into space. From startups to enterprise, we have, again, companies like Apple and Facebook and Oculus, for example, creating all sorts of things. And let's I'll pass it on to Dave again, and that's just my contact information there and our website if you guys are curious. And yeah, I'll pass it on to Dave.
Thank you, Roy. That was wonderful. You can go ahead and unshare your screen.
Yes.
And should have, in fact, I think, allowed you to complete. We're just so excited halfway through. So
no, that's perfectly fine. Yeah.
Thank you for your patience there. we want to have a round robin discussion on this, but what we'll do is we'll move to our intern speakers, where we want to recognize Sharanya's work, where the next step is creating a robot. And by the way, Sharanya, as you have a pick and place robot, I imagine that a refined version of it may be able to place the chips onto the Volterra, similar to Tony Stark in an early version of Iron Man, where that sort of thing. Do you think robotic will like that? Oh, you're on mute. Go ahead.
As long as Robotica is so cute, I don't want to give her a bark like Star Trek theme. I know you like like more of a bark like robot.
Borg like.
No. We want cute little Robotica. It's they're like Jarvis. Jarvis is a gentleman and Jarvis is like, he's doing the things, but we want a Robotica. We want a cute little version where she's running around and being very helpful. So no, we're not going to change her personality. Her personality is very important to everything that we're doing, and her personality is your personality, Sharanya. We're going to see a video now. Oh, my pleasure. You're going to see a video now where you met Sharanya, and her robot acts like her, kind of. It's really cute. I like it. There's some sort of synchronicity going on there. So what I'll do is I'm going to bring that up. So I'm going to share my screen again and introduce Aaron and Sharanya's work. So I'll do share screen 1, share the sound. And now this is where I get to tease you, Sharanya. So we had a meeting, Sharanya, myself, and Faisal yesterday in preparation, and Sharanya was like teasing me. And so now I get my revenge and get to tease her, but I'm a little concerned though, because Sharanya had some really good comeback. So this might backfire on me badly. Let's see how this goes, ladies and gentlemen. Can you see Dark Leaf, a classical quantum hybrid circuit? Okay, I'm just going to share with you some of the web pages that showed up. Well, thank you, Vera. And what struck me about this is the computer-aided design for quantum circuits that Sharanya has been creating, and she's actually got the computer-aided manufacturing again that Roy has provided. And what a fantastic presentation there, Roy, that you shared. And there we have, Roy spoke and Anya, and where's Aaron? Oh, Aaron's on the next one. We'll have to update that and recognize Aaron. We talked about this already, where Joe, thank you, Joe, he gave us some input, sometimes accidental, which became a wonderful presentation. I mean, we talked about the replica. Like, I'm a big Star Trek fan, so I really enjoyed that. Then we have the Quantum Daily. So the Quantum Daily created an article about us, and let's just look at that for a moment. The quantumdaily.com, by the way, is where we get our news. So the Dark Star Quantum Lab to reveal classical quantum hybrid circuit roadmap. We actually did show you a little bit of the circuitry. We're not going to show too much. We just want to show you that it can be done. And here's the picture. So here we have David, our CEO, with James. And James is our PCB expert, and there they have a board. Chime in, David, if you want to talk about the scene at any point in time.
That's a turbine drive controller right there.
Whoa. Okay, that's cool. I've been curious to ask you. I wanted to know. That's cool. So turbine drive, to me, that sounds like it could be mounted on things with turbines. Move, and they move quickly.
Likely like a mixing pad or something, there's a lot of exciting applications of turbines. This is probably, use for one of the lesser ones, but still cool.
Cool. I like that. Okay. Well, Sharanya, maybe we can put like a cute little turbine on Robotica. Wouldn't that be nice? We'll think about how. Now, here, Darkstar Quantum Lab, we had our press release, a low-cost quantum circuit capability roadmap, and that's available. No comments on here. Moving forward, we looked at Volterra. Thank you, Roy. That was exciting with Nova, and Nova is very dark starish, right? Like Nova, like supernova. Dark star is like a black hole. So it's like, whoa, we're having the same terminology. I was quite excited by that. Yeah. What popped up here is for another meetup. Malik will be, Malik is our space lawyer, and as part of the involving young women in quantum, where Aaron has a lot of boys that show up, 7 to 15-year-olds, and then what happens is the little 5-year-old sister will show up like this, and she'll go like this, and she'll be looking and peering. So we want to encourage very young girls, very young women to become involved. And we do that by having Vera, our media director, and Aaron's mom sing Disney princess songs. And that Disney princess songs have a beautiful theme. Because in the end, we want happiness, we want prosperity, we want peacefulness with prosperity. So it becomes very important that we start from the beginning. And how can we do this better than Vera? And I love hearing her singing. I don't think I can coax Vera, though, to sing a Disney princess song on this. So I'm not going to ask. But the idea here, Roy, is, and there's Malik right there. The idea here is that we're going to print pretty patterns that will be used as kind of makeup and as sort of tattoos, but they'll sparkle. With dark leaf powers, and then Sharanya, we're hoping you'll model them for us, and you'll be like 7 of 9 in Star Trek. So I'm just letting Sharanya know right now because it just popped up. So otherwise I was going to tell you, but okay, now you know my plans. So this is a website I put together. I think it was like 4 years ago, where I was offered $10 to $20 million in public-private partnership funding from a company called Guidehouse. It was a subsidiary where they want to see the circular economy show up. And they have a $1 trillion business plan called Energy Cloud 4.0, which is all about new technology, the stuff that Volterra is up to, the stuff that Elon Musk is up to. They're just seeing the light. They're an energy company. And they're saying if we go green, we'll eventually get the circular economy. And I had this picture created for me by one of our developers who will actually develop the mini towns in North America. And what I did was I added a 10-year-old boy, an Energy Cloud City circular quantum economy proposal. Aaron actually created a video about suffering and saving the world. And he deploys these as actual space stations. So Aaron is thinking a little bit further ahead than Darkstar had in mind. So Aaron's thinking leads our way. Now, just to walk you through it here, there's actually a music video that a couple of pop stars sang about Aaron, the Quantum Kid. It's all on this website. So there's Aaron. He makes faces like that. Right now, serious, but when we're talking, I like his faces. They're quite something. Here's his plan, by the way. Circular economy is at the middle. It's the UN 17 Sustainable Development Goals. Roy, we're looking for Volterra to be at the heart of creating all this tech. Here, Aaron has a message for the US Space Force, part of the project, which we're actually going to deliver to the US Space Force. And he's got all these kids, as I mentioned, who are part of this. This is a previous meetup where we're talking about this tech. And here we have Sharanya and Robotica. So this is designed by Sharanya, Robotica, the happy robot. And with Aaron and I, we came up with a plan where at the top right, there'll be a quantum drone where Sharanya will make friends with in our quantum garage, and we'll airlift it to Fort Bragg. And then everybody will be wavy dancing, of course, because there'll be happiness, because Sharanya represents happiness. And here's a detailed picture of the robot, Robotica, the quantum farm robot. So we're actually looking to make this happen, Roy, through your tech. We do have Sharanya created an active robot that has the bit of the Canada arm going here. We can go into this detail later, another meetup, in fact. But I'll point out this is the Aaron I sees all. So A for Aaron, I for I, AI. We just invented something, ladies and gentlemen. I think we're onto something. By the way, this is the ventures of Dark Star Adventures of Angela, which is his sister, his baby sister, Aaron's baby sister, or 5-year-old sister, the Disney princess singing daughter board of Vera. Vera is here with us, and Vera and Angela sing. They come into our meetings I have on the weekends with Aaron, and they sing Disney princess songs. It's quite delightful. So the idea here is the daughter board, which comes out of Volterra, and Vera the motherboard, and here they're holding the dark leaf. That's our sign for the dark leaf. So they're around this, and here we see Sharanya with Robotica here. And Sharanya, I never asked you this question. Are you making the same face as Robotica, or is Robotica making the same face as you? You're on mute. You're on mute.
Robotica making the face of mine.
Oh, she's mimicking Mummy. Okay, that's nice. And this, by the way, is a Imperial droid probe from Star Wars. I got excited, Roy, when you mentioned proximity probe, or it was a Cat who mentioned proximity probes, because when you said that, I thought of the Star Wars probe droid. So maybe we can like build that in there somewhere. Now continuing, we're very. Oh, say again, Roy.
Sorry, nope, nothing on my end.
Okay.
But
okay. And here we have the actual science fair, a technology fair that's going on. We were very excited about this, and we were showcasing this last night while Sharanya was writing her final exam for Centennial College Electronics. And what I wanted to do, though, is just to show you. So if you click that, you get this. And what's nice is that Centennial College highlighted the Robotica, where Robotica is envisioned by 10-year-olds, blah, blah, blah. It's very nice. There's actually a typo here. There's nothing approved. So I wanted to go on record to say that there's no approved project going on. This is supposed to say Envision project. So that's on me. It's not on Sharanya. It's my mistake. But what's very nice, though, is it describes the cartoon picture. But here we have the actual robot. And I'll just show you a short clip of it moving. That's Sharanya's feet. So I'll pause. That's her way of saying thank you, right, Sharanya?
Yes.
Kind of reminds me in church, where it's like you go like this. It reminds me of that. So I'll pause that. So this is, imagine that Sharanya, or rather that Robotica, because become self-aware. And now is on her way from Toronto to North Carolina, the 22,000 square foot quantum garage, where she'll make friends with a Imperial Star Wars looking droid. So let's continue the story. Now you notice the blue book. I just discovered before that Sharanya communicates with the robot with the blue book. We didn't get the details on that, but the way she moves it tells the robot. It's a way of communicating with the robot without programming. Is that correct, Sharanya?
Yes. It's the way of communicating with her without any coding.
Yeah, without encoding. So it's learning. There's a learning mechanism in there, because I observed the video and I see her getting smarter as time goes on. That's quite remarkable. Let's continue. Now that reminds me of budgies. That reminds me of those little birds. They make noise. They do that when they're happy. I was trying to figure out where that's from. That's what it is. So Sharanya, is she mimicking you? Like, do you when you're happy? Like, I'm teasing you now.
Yes, I wanted her to mimic me.
I think that's the sweetest thing. I haven't seen that behavior yet from you, Sharanya, but I think the robotica has spent more time with you than I have. I just think it's the cutest thing. Anyways, what we'll do is there's more about this, and there's what's nice too is I'll just move forward. Oh, here's some of the programming. So live, you can see what she's doing. Now, part of AI. What's important is to have transparency, where we want to know what it's thinking. And what I'm declaring here is Sharanya, in that we're able to see through a Python shell, we'll see how it's thinking, that we can even expose some of the AI so you know what it's thinking. It's like, is this person good or bad, right? Like, we're going to get into that. Mark my words. And then continuing here, then you have an exposure, and here we've got 1, 2, 3 PCBs that I can see. Is that correct, Sharanya?
Yes.
Okay, very good. And continuing. What I'd like to just highlight, just to recognize you, is this gentleman right here, which is your professor, right?
Yes, my technical project professor.
Yes, let's hear a word from, what's his name?
Professor Thomas.
Professor Thomas. Okay, like, look how impressed he is. I'm going to play this clip.
Looking at your video, I can't imagine all the work you've been through. Again, a solo effort, spanning, well, multidisciplinary technologies. I mean, even the mechanicals, the motors, the motor drivers, using the pulse width modulation control, as I see you've done. You had the sensor, the ultrasonic sensor, to interface with, and then there was the vision aspect. I know you're using OpenCV, something called NumPy, but to integrate all this and write the amount of code you did was, well, a tremendous effort. What can I say? These solo efforts just blow me away. So thanks for that.
And you said thank you, Professor, there. So yeah, well done, really well done, Sharanya. I have never seen robotics put together like this. I've tried to have my kids involved in this, and I have some sense of it. It's remarkable, and the fact that there's a personality, you're able to interact with the blue book. So it's like I didn't have time to code, so I'll give it some machine learning, and then the way I hold the book, it'll know what's going on. I have some preset routines going on. It's like, wow, I haven't begun to unpack that yet, but I really appreciate the genius around that. Roy, would you be proud to see Volterra printed circuits showing up in Robotica?
Oh, absolutely. Yeah, absolutely. We'd love to support that and integrate Volterra in any way we can, for sure.
Yeah, no, thank you. There, Sharanya, do you feel nice?
Yeah, thank you for that.
Oh, you're welcome.
It's a great acknowledgement from Daxter, and I think it's a pleasure moment for me. Thank you.
Wonderful.
Oh, nice. That's just a nice moment. Now, as part of this niceness too, we have mentioned QCI, where Sharanya is relevant. We have mentioned QCI, Quantum Computer Inc., with its $200 million Proxit market cap we were shared Dr. Faisal Shah Khan with, the next company to go on the stock market, and this has to do with Alexander Jivov, is where he's doing, as I mentioned before you showed up, Alexander, or right after you left, I talked about the important work that you're doing and understanding how big this is in terms of the financial marketplaces. Oh, there you are, Alexander. How are you?
Hey, I'm good. I'm good.
And what Sharanya and say hello to Sharanya. Sharanya, say hello to Alexander.
Hey, Sharanya.
Hello.
Yeah, you guys, I'm common in all the meetings, but this team is actually meeting for the first time in this meetup, where we are looking to IonQ with this $2 billion SPAC, special purpose acquisition company, where Alexander, and we can talk about that from you in a moment, to be able to appreciate what's happening to this quantum marketplace. In order to understand the value of the companies and making sure it's sustainable. Now, Sharanya is friends with Denise, Vice President of IonQ. Sharanya, you're part of her Women in Quantum program. You communicated with her and offered to promote her program from the words of Denise. Take it away, Sharanya.
Yes. I'd like to thank you for recommending for the quantum meetup with Women in Quantum. So nowadays we have the need for diverse environment in quantum. That was the main theme of the Women in Quantum meetup. So what I enjoyed most in the Women in Quantum meetup is there are so many women take the initiative to join the QTech, which is quantum technology. That meetup gave me a lot of connections with IonQ and Mr. Honk, who is the Andre Honk. He mentioned that being a newbie, I'm a newbie for quantum tech. He inspires more about my initiatives to learn quantum tech. And now I am registered in IonQ's mentor program, which to help the people who's having their desire to grow in quantum technology. I have received a text from Denise, so I can read out the text, what she said. So to my text, she mentioned that I would love it if you would mention the mentoring program. We are working really hard to get people to sign up and also getting some very prominent mentors. The program uses a phone app and we match the mentee and mentor, and then they both agree on next steps. What's great in that, the matches can be with the people that are not in your organization. So it gives you a broader point of view, plus helps you grow your personal network. Thanks, Denise. So it will be a great opportunity for me to grow my quantum tech contacts. And I'm so thankful to Dave, my mentor, for this great opportunity.
Oh, you're very kind with I'm representing the team, and I did find you. I have bragging rights on finding you, and I think I tease you the most. But
Yes.
all the support has come from the team. And Sharanya, the message there I think is to Joe's friends, the women that is in Joe's network, as a welcome to learn more about quantum from arguably become the most instant, powerful, and most advanced hardware quantum computer out there. I think they have a desktop quantum computer on their roadmap. So this is legendary stuff, and what we're doing is through you, Sharanya, you're representing your access to us to what Denise is doing, and the gentleman who you mentioned, who's very kind. He's been very kind to you, hasn't he?
Yes, he's very kind, and he welcomes everyone to get into quantum tech, and he appreciates whatever the efforts we are making.
Yes, it's very, very nice. And what's his name again? I keep forgetting his name.
Andre Honk.
Yes.
Can I tap it on the
chat? Please, yeah. And do you have the link? Can you provide is the link handy for any women who want to become part of the mentoring program?
I'm not sure whether I have the link handy.
That's okay. What we'll do is we'll get the link, and we'll put it on we'll publish something just for Denise and you.
Yes.
We'll write it up later and put it on the Dark Star LinkedIn, Dark Star LinkedIn.
Yes.
Okay, we'll do that. Very nice. Okay. Now, so thank you for that, and this is part of our inclusivity, and we're doing what we can to support women in quantum. And thank you, Sharanya, because you're officially, I think, a representative of that organization now. Certainly with the statement that you made.
Thank you.
Our pleasure. Now we have 9 minutes left, and Aaron has been drawing. I can see him drawing stuff. Aaron, how's it going?
So, first of all, I raised my hand like some time ago, but like you didn't see me. So what I've been doing, I've been on notes since like there's a lot of people on Zoom and it's really laggy and it's like buggy. So I took notes on my iPad for the next drawing, like for Robotica and everything.
Oh, that's brilliant. I appreciate that. So we'll get together at 10 o'clock tomorrow, and we'll go through that. From your point of view, as you are the chair of the Quantum Kid youth group, and the two of your members joined us today. Aaron, you have been part of our meetups almost from the beginning. Do you have any comments, any thoughts, any creative ideas that you want to share right now? I know they will be shared through your drawing, and I don't want to do it in advance. If you have an idea, do it later. But do you have any thoughts in terms of what you've heard today, how you feel about Sharanya's work and seeing the flexible printing that Roy represents?
So yeah, this is sort of all coming together on I think yesterday, right? We talked about how, well, I think it was Zachary or Isaac or someone else that brought up that there's going to be a slime around Robotica or something. And yes, Zachary?
It was me, the idea of the slime.
Yeah, so maybe the flexible, I forgot what it's called. The
circuits.
Yeah, the circuits would come in handy because, well, slime is very liquidy, and liquidy equals bendy.
Yes, and we had talked about the magnetic slime as a predecessor to Terminator T1000. Which is an ultimate expression of, I think, where Roy's technology is going. Flexibility, where it can become liquid at one point, but become hard at the end. And that is actually what we're looking to find out through Dr. Faisal Shah Khan. What is the scientific underpinning of that as we move forward with our approach to create active Ironman type suits. So we'll address that at a later spot. But thank you, Aaron, for mentioning, because the magnetic slime is actually part of the the necessary lubrication that's required for high-speed vehicles to keep it cool. So that was a fun way of introducing it. Thank you. Well, we have 5 minutes left in our time. Alex, perhaps we can have a quick word from you. We had a nice meeting on Friday about the financial side of things, and I hope the minutes I provided captured it. Now, we've done the financial part. You've been part of the meetup scene since July, when we launched the York University Quantum Computing for Social Impact group. You've been my star student, and you bring hope. Hopeful, which is your company name, in providing hope for not-for-profits to use AI to tell a better story. I hope I did that justice. Please correct me if I'm wrong. And your thoughts about today's meetup and the relevance of the Moore's law scaling possibility for what the quantum ecosystem can actually become. Alex.
Absolutely. Well, Dave, you always do hopeful justice and me great justice. So thank you. Thank you as always. And I think this is a fantastic meetup, everyone. So thank you, everyone, for putting it on. I'll be very quick because I know we're just right at the end and I don't want to get too far down the rabbit hole. But in terms of what we've been seeing today, I think there's a tremendous amount of possibility for the quantum market as a whole from a financial perspective to grow much more quickly than any of the other advanced technologies. My specialization is in artificial intelligence and quantum, but I think the quantum market will scale much more rapidly than the AI market has in the past 5 to 10 years. And this really just reinforces it from what we've seen today. Specific to Moore's law, my biggest question as myself and my team are putting together the Quantum Amplify project, which is encouraging the creation of a quantum ETF and private investment into pure play private quantum firms, is that it's such a radical shift in processing power and such a rapid rise in processing power and the ability to transfer data that I think it really has the capability to break Moore's law as we know it. And that's really what we're trying to examine on our side. And I think I'll leave it at that, Dave, because otherwise we're going to have to start going down the numbers rabbit hole, and we only have a few minutes left.
Yes. Well, thank you, Alex. That was excellent feedback and exciting, because you're looking at that from a point of view of what is practical, not from us who are on the inside thinking that this is going to have a lot of thinking that it will work. You're able to see from the outside, from the financial point of view, and take a third-party point of view. So appreciate your words. Thank you. So we've heard from Aaron. We'll go into closing remarks now. And Mr. Wilkinson, actually, we'll come back to you. We'll come back to you in the end. Roy, thank you very much for that wonderful presentation. And it's very exciting. Any closing remarks?
Yeah, I just wanted to say thank you to everybody for joining and listening in on Volterra and what we're doing at Volterra. I appreciate it. And thank you, Dave and Dark Star team, for setting this up and putting this together.
Oh, it's our pleasure. You really did us justice, and you did a lot of work on short-term notice. There's a lot of work you did behind the scenes that was not shown, setting us up so that if we wanted to actually show live circuitry, you were prepared for that. And we just chose last minute not to do that, thinking that it's exposing a little bit too much. But I think we've never run a flavor for what this represents. So thank you for that. And oh, a pleasure. I will turn to David Wilkinson. Your closing thoughts.
Yeah, great job, Roy. Great job, Saranya. Everybody thank you, everybody, for being here. Alex, appreciate you popping in and talking about the ETF stuff. Everybody just want to say thank you and look forward to talking more.
Oh, thank you, David. If Joe, if you wanted to have any closing remarks, not to put you on the spot, but love to hear from you.
Yep, sorry about that. Yeah, definitely wouldn't overshadow David, based on what's been put already. And Dave, thanks for the invitation as well. Roy, a great work. Sharana as well, great work. Don't give up on the drive. I have so many questions that I'll save for David and Faisal and Dave's that conversation. And I look forward to seeing you guys in the future.
Oh, thank you, Joy. Thank you, Joe. You are a joy. And those are my closing remarks. Vera, thank you for your help. And I will turn this back to you, Faisal, for your remarks and to close the meeting.
Thank you so much, Dave. Thank you, everybody, the audience who made some time today on a Saturday to hang out with us and learn some really cool stuff from Roy's presentation, which was amazing, and also hear from Charania and her Robotica robot, which was awesome. I really enjoyed looking at that robot perform. Aaron, thank you so much for your input, and Alex, we need to connect a little bit later, I suppose, if not today or tomorrow, then Monday. And David, thank you so much for your comments. Joe, thank you for joining us, and I hope this was a learning experience, I guess, for everybody. It certainly was for me. So we look forward to our next event, and please stay tuned. I'll be announcing some more events, and hope to see you all there. Thank you very much for coming, and have a great weekend.